Hey, hello, 123 students. I thought I better say something about the first law of thermodynamics here, because there are two traditional ways of doing it, and there's been some questions already. The Survey book does one way, kind of a way I like. And the OpenStax book does the other convention. And it has its advantages that you'll see later on. But let me explain. The first law of thermodynamics is really just a conservation of energy principle. It says if you take a a substance, any substance, but I'll just say a gas, since that tends to be the easiest to work with and what we're going to talk about the most. And maybe you trap the gas inside a cylinder that's got this piston in it. That's important so we can push down or pull up on the gas. And so here's our gas molecules. But we like to say that there is some energy in here. And that energy then can increase or decrease. So we call it the internal energy. And so if we go to calculate the change in internal energy, it can come by either adding energy by heating it or by adding energy by putting a force on it. So that was what the video lecture was trying to show here, that, okay, you could add energy by putting heat to it, but you could also add energy by squishing it. And so the energy goes up. And the Survey book, and a good tradition here, is to say if energy goes in, that's positive, and if energy comes out, that's negative. So a positive delta E would mean there is a increase in internal energy. It's quite possible that something like this happens. It's quite possible you put heat energy in, so call it positive. Then as a result, maybe the piston goes up. Now, that would be then taking energy out of the gas. You're pushing on the atmosphere. So then the Q, the heat, would be positive, but the work would be negative. And I suppose it's even possible that those two are balances, and so the total change of internal energy is zero. There is no gain in energy. It's a little bit like, putting water in a bucket and then it drains out. And if what you put in equals what drains out, there's no gain in water in it. Of course, it's also possible that one is bigger than the other, and so the change in energy is a net positive or a net negative. But the point is, this is just a conservation of energy statement. So if you define all energies going in, so in as positives and out as negatives, you get a simple statement of conservation of energy, the Q plus the W. These are the two ways of adding energy to our system. And that's kind of the whole lecture idea, is to make sure you realize that thermodynamics doesn't just involve heat, it also involves work. And so there are two types of, or two forms of energy we can put into here. And like I said, I like that. However, there can be some confusion, because the OpenStax book, and probably about half the books on the market, do this the other way. And the other way is to do this. It sounds kind of weird at first, but it does have its advantages. And that is to say that if you have your gas, and so here's your gas with your piston, and if you put heat into it, call that positive, and if heat comes out, call that negative. So that's the same, but here's where it's different. If work comes out, call that positive, and if work goes in, call that negative. Now, what's nice about that, you will see, is that a lot of times when we're working with thermodynamics, our goal is to do something like this. That is, we put heat energy in to our engine, so we burn gasoline, and then our engine does work making the car move down the road. So I do want to point out that there is something nice about this definition, and that is things that are positive are the normal process. Heat in, work out, okay? And the negatives are the abnormal processes. However, we will deal with that in the survey book by just looking at the absolute value of the work. We will just say, okay, the work came down and we want it to come out, so it's a negative number. But sometimes we don't like to look at negative, so we do the absolute value. So again, I like this approach that the survey does, but there is no right or wrong, and it's kind of good that you're coming across maybe seeing both of them. But for those of you spending time in the OpenStax book, you're going to see this. You're going to see something that says, okay, the change in internal energy of your system is equal to. And it would be then the energy going in, and we can just write that as a Q because positive in and negative out. Here's where it gets kind of weird then. You would say add the energy, but it would be negative of the energy, right? Because if you're putting energy in, you're going to call that a negative number, and the negative of a negative is a positive. And so you just write this as Q minus W. And I got to admit, that does not look to me like conservation of energy. That is not saying take the two energies, add them together, and that gives you your total. But that is really what that's saying because of your definition of work being a negative number. So that's the good and bad. So in the survey book, you will see the first law of thermodynamics written with a plus sign. In the OpenStax book, you will see the first law of thermodynamics written as a negative sign. It also means that in the survey book, the work would be negative the integral of P dV, whereas in the OpenStax book, the work would be a positive integral of P dV. And when we want our engine to do something, in the survey book, we are happy with negative numbers. We want them to be negative. We want our engine to do something. We want the energy to go from the gas into the environment. We want it to go from the hot gases in the car's engine to making the car move. So we like negative numbers. And then since we really don't like negative numbers, we'll talk about its absolute value. And in the OpenStax book, when we get into chapters 22, we will then, of course, like positive numbers because we want the energy, again, to come out, and we're defining it as a positive number. So as I got a couple of questions, and I just thought I should clarify that. I tried to give you that little hint in Sunday's email, but you hadn't really looked at Chapter 20 yet. You still might be struggling along with Chapter 20 and not even recognize this different form. Maybe you only look at one book, so it's not confusing. But if you're looking at the OpenStax and then you're trying to do the calculations from a homework, you might have a negative sign issue with the work because the way they treat it differently in the OpenStax than in the survey. And like I said, it's pretty common. If you pick up any physics textbook, half of them will do this and half of them will do that. There's good and bad in both, and so authors pick one way or the other. I'm a bigger fan of this one, but I got to admit it's got its problems later on. That is why many books do this. All right. Hope the clarification helps a little.